The concept of a harmonic triad provides a structured way to understand the interconnected relationships among three elements, where each pairwise combination influences the third in a balanced manner. This approach is particularly useful in scientific and engineering contexts where multiple variables interact with each other in predictable ways. In this discussion, we will explore the harmonic triad through the lens of temperature, pressure, and volume, three fundamental properties that govern the behavior of gases. By examining these properties and their interrelationships, we can gain a deeper understanding of key gas laws, which are crucial for various applications ranging from everyday phenomena to advanced engineering systems. Harmonic triad, temperature, pressure, and volume. Let's delve into their interrelationships. Temperature and pressure, as described by the ideal gas law. For a given amount of gas and a constant volume, the pressure of a gas is directly proportional to its temperature. This implies that as the temperature of the gas increases, its pressure also increases, assuming the volume remains unchanged. In practical terms, when you heat a gas inside a rigid container, where volume is constant, the gas molecules move more vigorously, leading to more frequent and forceful collisions with the container walls, thereby increasing the pressure. Pressure and volume, following Boyle's law. For a constant temperature, the pressure of a gas is inversely proportional to its volume. This means that if the volume of the gas decreases, its pressure increases, provided the temperature remains constant. When a gas is compressed into a smaller volume, the gas molecules are forced closer together, resulting in more collisions per unit area, and thus higher pressure. Charles's law indicates that, at a constant pressure, the volume of a gas is directly proportional to its temperature. This means that as the temperature of a gas increases, its volume also increases, provided the pressure remains constant. The implication here is quite straightforward. When a gas is heated at a constant pressure, it expands. This is exactly why a balloon inflates when the air inside is heated. The increase in temperature causes the gas to expand, thereby increasing the volume. In the framework of a harmonic triad, the interdependencies among temperature, pressure, and volume can be summarized as follows. Temperature and pressure influence volume. A combination of high temperature and high pressure typically results in an expansion of volume, assuming the gas can expand. This is described by both the ideal gas law and Charles's law, which predict that an increase in temperature at constant pressure results in increased volume. Moving on, temperature and volume influence pressure. When both temperature and volume increase, the resulting pressure depends on the balance between these changes. If the increase in volume sufficiently compensates for the rise in temperature, the pressure might remain stable. However, if the volume does not increase enough, the pressure will rise. Lastly, pressure and volume influence temperature. For a fixed amount of gas, increasing the pressure while decreasing the volume generally leads to an increase in temperature, as described by Boyle's law and the principles of thermodynamics, where work done on the gas during compression increases its internal energy. Understanding the harmonic triad of temperature, pressure, and volume is fundamental in the study of gas behavior. These relationships form the basis for important gas laws. Ideal gas law, which describes the combined effects of temperature, pressure, and volume on a gas. Boyle's law, which describes the inverse relationship between pressure and volume at constant temperature. And Charles's law, which describes the direct relationship between volume and temperature at constant pressure. The exploration of the harmonic triad comprising temperature, pressure, and volume reveals critical insights into the interconnected nature of these fundamental properties in gas behavior. This triadic relationship provides a structured framework to understand how changes in one variable affect the others, offering valuable lessons that extend beyond theoretical physics to practical applications in various scientific and engineering fields. The harmonic triad demonstrates that the behavior of gases is governed by predictable laws. Understanding the relationship between temperature, pressure, and volume allows for precise predictions and control of gas behavior in different conditions. This predictability is foundational in designing systems where gas behavior plays a crucial role, such as in engines and HVAC systems. The triadic approach emphasizes the importance of considering all three variables together rather than in isolation. This holistic perspective is essential for accurately modeling real-world systems where multiple factors simultaneously influence outcomes. For example, in meteorology, predicting weather patterns requires an integrated understanding of how temperature, pressure, and volume interact in the atmosphere. The practical applications of understanding these interrelationships are vast. In engineering, insights from the harmonic triad inform the design and optimization of pressure vessels, ensuring safety and efficiency. In everyday life, simple actions like inflating a balloon or using a pressure cooker are based on principles derived from these fundamental relationships.